Polarity of molecules. Now supposing we look at this molecule. In this, covalent bonding has taken place, and covalent bonding involves sharing of electrons. You know it pretty well. Covalent bonding means sharing. So if we look at this molecule of hydrogen, this is a homoatomic molecule, and this electron pair is equally shared between both the hydrogen atoms. As a result, neither has a positive charge or a negative charge. So none of them has a positive charge or a negative charge, as the electrons are equally shared between them. But supposing we have a molecule like this, in which chlorine is highly electronegative. Now because it is electronegative, you know the electronic configuration of chlorine is 2h7. So it's hungry for one electron. So what happens is, this electron pair, which should be in between chlorine and hydrogen, it should be in the middle of the orbitals of hydrogen and chlorine, it is actually drifted more towards chlorine. That is, this actually is the position. That is, this electron pair is more towards chlorine, because of which hydrogen gets a partial positive charge and this gets a partial negative charge. Now this leads to development of polarity in the molecule. So whenever you have a molecule in which one of the atom is electronegative, in that case polarity, the molecule will become polar. So these are called polar covalent compounds. That is, there is development of polarity even in covalent compounds. In ionic compounds, of course, there is polarity, the molecules are polar, but in covalent compounds also, if there happens to be an electronegative atom, there will be development of polarity. Another example is hydrogen fluoride. So this has a partial negative charge, this has a partial positive charge. Now development of polarity leads to dipole moment. Dipole moment. Let's consider this molecule. Let's say hydrogen. This is a positive charge and this has a negative charge. Chlorine is highly electronegative and hydrogen is highly, you can say, electropositive. Right? Now whenever there is difference of electronegativity, dipole moment is there. Now what actually is dipole moment? What is the formula for dipole moment? Dipole moment, which I'll be writing my dm over here, it is represented by mu, and this mu is equal to q into d. Here q is magnitude of charge on a molecule, or the magnitude of charge, and d is distance between the charges. For example, you have a positive charge here and you have a negative charge here. The distance of separation between the charges is d. Okay. The unit of dipole moment is dy. Now, if the difference of electronegativity is more than 0.5, then the molecule is supposed to be ionic. If it is less than 0.5, the molecule is supposed to be covalent. Applications of dipole moment. First is percentage ionic character can be calculated. Second is geometry of the molecule can be predicted. And third is predicting the nature of molecule, whether it is polar or non-polar.